Hello guys, please tell me whether audio and video is clear or not. So good evening everyone, I hope everyone is fine there. So today I'm taking Parmanu series for Barc, and I hope you are enjoying this series, especially those students who are preparing for Barc exam. And in this series, today the session is about power electronics. Okay, so I have selected some questions. There are 6 to 7 questions in power electronics that I want to discuss in this session, and actually we both will discuss these questions. So let's start this session, and I hope you are enjoying this series, and I hope your preparation for Barc is going well. Okay, so tell me guys, is audio and video clear? Tell me everyone, is audio and video clear? Please comment in the chat section. Tell me whether audio and video is clear or not. So today I have one more session, and that session will be at 9 p.m. and that session is all about fundamentals. So in that session we'll discuss about network theory and basic laws of network theory. Okay, so I think audio and video is clear. Okay, so let's start the session guys. So before starting the session, there is some introduction part. So let's complete that. This is my introduction. My name is Asu Jangda, and I teach almost every subject. And right now I am teaching for Barc, and this series is Parmanu series. Okay, we have started one series for GATE 2024. That is GATE 2024 fundamentals. So in this series, the fundamental subjects are going on, and this session will be at 9 p.m. today itself. And we will study about basic laws in that session. Okay, so don't forget to attend that session also. There is one 90% scholarship program. You have to give the scholarship test for that. Those students who are not financially good, so they can apply for that test. The link is given in the description, so you can register yourself and you can avail this scholarship. Okay, so don't forget to like this session guys, and please subscribe our channel if you have not subscribed it, and press the bell icon so that you get the notification whenever my session is live. Okay, so I think it's time to start the session. Let's start guys. So the first question on your screen is, you can see that a half bridge controlled converter is operating from an RMS input voltage of 120 volt. It means, first of all, two things are given. Two things are provided to us. The first thing is half controlled bridge converter. Half controlled means semi converter. So you can make the converter like this. If you want to, you can take the converter like this. There are two thyristor, two diodes. Okay, so this is my converter, and it is given that the input voltage RMS is 120 volt. Okay, input voltage RMS is 120 volt. What are the mean load voltage? It means average load voltage at the firing angle delay of 0 degree and 180 degree. We need to calculate the output voltage, average output voltage across this load. We need to calculate average output voltage at alpha equal to 0 degree and 180 degree. Now the question is, we don't know about the load. So how to calculate the output voltage? Let's assume that the load is such that the current remain continuous. Let's assume it like this. Now for alpha equal to 0 degree and for 180 degree, we need to calculate output voltage. What will be the output voltage? Tell me guys. सर जी इंटरव्यू क्वेश्चन सीरीज आप लेने वाले हैं क्या? हाँ, इंटरव्यू क्वेश्चन सीरीज भी मैं लेने वाला हूँ, बहुत जल्दी उसका भी अनाउंस करेंगे. तो आप एक बार इस क्वेश्चन को, इन क्वेश्चंस को एक बार डिस्कस करते हैं, और जल्दी ही आपको इंटरव्यू सीरीज के बारे में भी हम अनाउंसमेंट करेंगे, सो दैट आप जो है उसका भी फायदा उठा सके. ओके, सो बताइए दोस्तों, इस क्वेश्चन का आंसर दीजिए. I have drawn the diagram, so please tell me which option is correct. For 0 degree and for 180 degree, we need to calculate average output voltage. Tell me guys, tell me everyone. Do it fast. Do it fast. It's a semi converter. It's a semi converter, and nothing is given about the load. Let's assume that the load is continuous conduction. The load current is constant. Let's assume it like this. Okay. So now tell me, what should be the answer? Do it fast, everyone. Do it fast. Let's see how many of you can solve it. Do it fast. Tell me which option is correct. Tell me which option is correct. Do it fast. Do it fast, everyone. Do it fast. You have 2 minutes. Tell me which option is correct. Tell me which option is correct. Do it fast, everyone. Okay, I think it's my turn because nobody is replying. So let me solve this question, guys. We have semi-converter. In semi-converter, the output average voltage is V0T average will be equal to Vm by pi into 1 plus cos alpha. Okay. This will be my average output voltage. For alpha equal to 0, the average output voltage will be 2 Vm by pi. Okay. And for alpha equal to 180 degree, average output voltage will be 0 voltage. Okay. So the answer either A or C, because for 180 degree, it has to be 0. In these options, for 180 degree, average output voltage is not 0. That's why B and D is wrong. Now let's come to A and C. Because for 180 degree conduction, cos 180 is minus 1, it will cancel out and you will get 0 answer. Now the question is, for alpha equal to 0 degree, it will be 2 Vm by pi. Okay. V0T average will be 2 Vm by pi. Now what is Vm value? Vm value is 120 root 2, because 120 is the RMS value. 2 into Vm. Vm is this divided by pi. This will be my average output voltage. Okay. So the answer should be Agra. Answer should be Agra. Okay. I hope it is clear, guys. The question was very simple and you can easily solve this question like this. But you should remember this formula for semi-converter. Even if you don't remember it, you can draw the output voltage wave shape. Okay. You can draw the output voltage wave shape and you can check which formula is correct and how to solve this question. Okay. So I think it's a simple question and you can easily solve it. Let's come to the next question. In the next question, it is given that a solar cell of 350 volt is feeding a power to AC supply of 440 volt. There is a solar cell of 350 volt and it is feeding power to an AC supply of 440 volt, 50 hertz through a 3-phase fully controlled bridge converter. Okay. So it means the load is type RLE type of load. Okay. And it is feeding the power from the load side to the source side. Large inductance is connected in the DC circuit to maintain a DC current constant at 20 ampere. If the solar cell resistance is 0.5 ohm, then each thyristor will be reversed biased for how much period? Okay. So the question is like this. We have a 3-phase converter. We have a 3-phase converter like this. And it is given that this is A phase, this is B phase, and here we have C phase. Okay. And here the load is RLE. Now let's change the polarity of E. Let's change the polarity of E. Why I'm changing the polarity? Because then only you can supply the power from the load side to the source side. Okay. So this is the type of circuit. Now it is given that it's of 350 volt and the current is constant at 20 ampere. Current is constant at 20 ampere. Okay. So you can see that it is delivering the power. Okay. This source will deliver the power to the supply side. Okay. And the supply side has line voltage RMS as 440 volt, 50 hertz. Okay. Line voltage RMS value is 440 volt, supply, and the frequency is 50 hertz. Okay. The inductance is connected in the DC circuit to maintain the DC current at 20 ampere. solar cell resistance is also provided to you, 0.5 ohm. Okay, and L is very high, let's say. Then each thyristor will be reverse biased for a period of, we need to calculate for how much period the thyristor will be reverse biased. So I think it's a simple question. What you can do is, you can draw the output voltage wave shape. You can draw the output voltage wave shape. Since the conduction is continuous, then the average output voltage, first you calculate alpha, na? Average output voltage will be 3 root 3 Vm by pi cos alpha. Okay, this will be my average output voltage in 3-phase full converter if the conduction is continuous. We know that this current is 20 ampere and this voltage is of 350 volt. Now, what is the average output voltage? The average voltage across inductor is 0. And we know that this drop has to be of 20 into 0.5, that is of 10 volt. It means the average output voltage of this polarity has to be 350. I mean 350 is of opposite polarity, okay? And this 10 is of opposite polarity. So the total voltage of this polarity will be minus 340, okay? So this will be minus 340. Now from here you calculate alpha first. First you try to calculate alpha, okay? Because we know that the average output voltage is negative. That's why this is supplying the power, okay? And you can see that the solar cell is 350 volt. It has some internal resistance and some inductance, and the current remains constant at 20 ampere. Since the current remains constant, it means the conduction is continuous. If the conduction is continuous, the average output voltage will be 3 root 3 Vm by pi cos alpha. Now we need to calculate the average output voltage. So the average output voltage will be 350 minus this, because it has opposite. So 340 of this polarity, but we don't require this polarity. We require opposite polarity, output voltage of opposite polarity. So let's call it minus 340. From here you can calculate alpha, okay? So alpha will be equal to cos inverse of minus 340 into pi divided by 3 root 3 Vm. Vm is the phase voltage maximum value. This is the RMS value of line voltage. So RMS value of the phase voltage will be, this is the RMS value of phase voltage, and the maximum value of phase voltage is 440 by root 3 into root 2, okay? This is the, you can say, RMS value of the, this is the maximum value of the phase voltage. So now you can cancel this and calculate alpha. It should be greater than 90. So first calculate the value of alpha so that we can understand for how, at what instant this thyristor will start conducting. So first let's calculate this alpha. How to calculate that? Okay, so you have to do some calculation, guys. So please tell me, what is the firing angle alpha? I think alpha came out to be, tell me what is the value of alpha? Alpha came out to be 125. Is it clear? Tell me, guys. Is it clear? Solar cell is feeding power to AC supply. Yes, through a bridge converter. I think this is correct. So now you can calculate alpha. Alpha came out to be, I think alpha came out to be 125. Okay. Alpha came out to be 125. Please check this value because my calculation is not good. 120, is it 120? Is it 120 or 125? Tell me, is it 120 or 125? What is the value of alpha, Sachin Tiwari? Please tell me what is the value of alpha. You have to calculate the value of alpha first. Okay. Tell me what is the value of alpha. From here you can calculate the value of alpha. From this calculation you can calculate the value of alpha. Okay, Abdul. Okay, at 9 p.m. we have network class, but not now. It's Barc session. Okay, so it is 125 degree. Okay, thank you. So we found that alpha came out to be 125 degree. Now the question is, they don't ask you about this firing angle. They are asking each thyristor will be reverse biased for how much period? For how much period each thyristor will get reverse biased? So to find that, we know that the output voltage will look like this. If I need to plot the output voltage wave shape, then output voltage wave shape you can plot it easily. And let me plot the output voltage for you. You can see that output voltage will be the line voltage. So this is the way to plot the output voltage. Okay. These are the line voltages. Similarly, in the lower half. Okay. Now we can say that this is the origin. So this is VAB and this is VAC. After that, this will be VBC. And then it will be VBA. And then VCA. And then VCB. Okay. And after that it will be VAB. Okay, VAB. It means before VAB we have VCB. This is my VCB voltage. Okay, so this will be the line voltage. Now the question is, the firing angle is not 0. The firing angle is 125 degree. Now since the conduction is continuous, you can see that every thyristor conduct for 120 degree. 60 and 60 this. You can use the upper subscript. No? The upper subscript is A. It means at this point A is available. It means T1 is conducting. So T1 is conducting for 120 degree. Okay. Now after 360 degree again T1 will conduct. It means under one cycle, in one cycle, if you take entire 360 degree angle, for 120 degree this T1 is conducting. It means for the remaining 360 minus 120, for that interval T1 will be reverse bias. Now the question is, sir, alpha is 125. Does it affect the conduction of this T1 thyristor? No, sir. Why not? Because the conduction is continuous. Since the conduction is continuous, you can say that in entire 360 degree interval, this T1 will conduct only for 120 degree. For 240 degree, it will remain reverse biased. Okay. For 240 degree, T1 will remain reverse biased. Now, there is no such option as 240 degree. Okay. Because the question is, each thyristor will be reverse biased for a period of, for how much period the thyristor will get reverse biased. We need to understand that. Okay, so let's try to understand it. We know that VAB, the alpha for this is 125. 125 means here it is 60, here it is 120. So at this instant, T1 will get fired. Okay, T1 will get fired. And from this point onward, from this point to the next, you can say, and the next point will be, I mean, there is no point, there is no need of checking this. Nah. We know that the conduction is continuous. In continuous conduction, if this thyristor is not conducting, some other thyristor must be conducting. Okay, some other thyristor must be conducting. It means you can say that it will be reverse biased for the remaining interval. And the remaining interval is, we know that the entire interval is of 360 degree. Now out of that 360 degree, for 120 degree this thyristor has to conduct. For 120 degree this thyristor has to conduct. It means, what about the remaining 240 interval? For 240 degree other thyristors are conducting. If other thyristors are conducting, it means this thyristor will be reverse biased. Is it correct? I think it's not correct. I think there is a catch in this question. Now, what is the catch in this question? We need to check for how much interval this thyristor T1 will be reverse biased. So, what we can do is, we can plot the voltage across T1. We can plot the voltage across thyristor T1. Now, how to plot the voltage across thyristor T1? Okay, so let's try to plot the voltage across the thyristor T1. So, what we can do is, I need a blank space. Okay, so let's erase this for the time being. and let's use this space. We know that alpha is 125 degree. Now this is a good question actually. Okay, we need to check for what interval the thyristor T1 will be reverse biased for continuous conduction. So let's try to plot the voltage across the thyristor T1. Voltage across the thyristor T1. Okay. Now you can see that if I plot the output voltage, since the firing angle alpha is 125 degree, so VAB will start conducting at this instant. Okay, from this instant to this instant, output voltage will be VAB. It means output voltage will be like this. Okay, it will be like this. Now from this interval onward, from this point onward, output voltage will be VAC. Output voltage will be VAC. Is it fine, guys? So this will be my output voltage and its average value is minus 340. Now the question is, if I want to plot voltage across thyristor T1, obviously from this interval to this interval, this T1 will be forward biased. It means the voltage across this thyristor T1 is 0. So from this interval, let's call this interval as, what is this interval? Tell me, guys. This is 60, this is 30, 30 plus alpha. Okay. From pi by 6 plus alpha to next 120 degree. To next 120 degree. Just add 120 to it. So it will become 5 pi by 6 plus alpha. From pi by 6 plus alpha to 5 pi by 6 plus alpha, VT1 is 0. Voltage across the thyristor T1 will be 0. Now, what will happen after that? After this interval, what will happen, guys? VAB, VBC will conduct. It means the upper point will be the B and the lower point will be C. Okay. So you can say that the upper point will be at B phase. It will be, the B phase is available here. And at this point you have A phase. So the voltage across the thyristor will be VAB. Voltage across the thyristor will be VAB. You can see that this point is A, this point is B. So you can see that VAB at this instant, VAB will be, after this instant, this will be my VAB. Okay, this is a complex situation now. It's a complex situation. This is a complex situation. I mean, it's a very difficult to analyze this way. It's very difficult and very lengthy to analyze this way. So is there any other way? Is there any other way to analyze? Because it's a very lengthy process to check in what interval this thyristor, under what interval this thyristor T1 will be reverse biased. Answer is not 240. Let me tell you guys, because if you are thinking that for 360 degree, the entire interval is 360 degree, only for 120 degree, this T1 is conducting, and you subtract 120 from it, you will get 240 answer. It means if you are thinking that for 240 degree, it will remain reverse bias, it's not true. Why it's not true? Because after some time, it will again be forward biased. And if it is forward biased, then only you can fire it. Okay. If it is forward biased, then only you can fire it. Okay. So it means you can see that in this 240 degree, it will be reverse biased for some interval. And for some interval, it will be forward biased. Now we need to calculate for what interval it will be reverse biased. That's a thing that we need to find. Okay. Now how to calculate that? How to calculate that? Tell me, guys, how to calculate that? Only thing is you have to use the wave shape. Okay. So let's skip this question for the time being. I will solve this question at the last of this session. Okay. Till then we can solve the next question. Okay. Because it's a time consuming question, because I don't think that it's easy to solve using the waveform, because the waveform is taking very much time. Okay. So let's come to the next question first, so that we can solve it, and then we will revisit that question. Okay. So look at this question, guys. In the single phase rectifier shown in the figure, Vs is the sinusoidal voltage with RMS value of 120 volt. This is 120 volt RMS voltage. Okay. 120 volt RMS voltage, and frequency is 60 hertz. Okay. and Ls is of 1 millihenry. This is of 1 millihenry, and E is of 150 volt. This is 150 volt. Now, from I naught waveform, I naught peak value, we need to calculate I naught peak. We need to calculate I naught peak. How to calculate this I naught peak? I think it's easy peasy. Let's call it D1, this is D2, this is D3, and this is D4. We know that. Let's plot the waveform, supply voltage. This is my supply voltage, and the peak value of the supply voltage is 120 root 2. 120 root 2. This is the peak value of the supply voltage, and the output voltage is of 150 volt. Okay, now we know that if you want to fire them, D1, D2, you can only fire D1, D2 at this instant. At this instant, you can only fire the thyristor D1, D2. Okay, because this Vs has to be greater than 150. Then only the D1, D2 will start conducting. If they start conducting, obviously the current will start flowing. Okay, and current will be maximum at this instant. And because from this interval, from this instant to this instant, the voltage across inductor will be positive. This will be the voltage across inductor. If this is the voltage across inductor, then you can say that the current will be rising. Current will be rising. Okay, so the current will reach the maximum. So let's say at this instant, the conduction has started. Up to this instant, the current will reach to the maximum. Now what will happen after that? After this point, you can say that the supply voltage is less than 150 volt. But D1, D2 has to conduct. Why it has to conduct? Because current current need the path. Since the current requires the path, that's why the current will keep flowing via D1, D2. It means the output voltage will remain like this, and the supply voltage will remain like this, and output voltage will remain at 150 degree. And you can see that the 150 volt is greater than the supply voltage, so the current has to decrease now. Current has to decrease. Now the question is, up to what instant this current will go down? Up to what instant the current will go down? Now how to check it? Obviously at this instant, the supply has a reverse polarity. If the supply has a reverse polarity, will the diode D3, D4 conduct now? Answer is no, sir. Why? Because the current is flowing via this path, and diode D3, D4 will conduct only if this current has become zero. Then only you can say that D3, D4 will start conducting. It means you have to check at what instant this current has become zero. At that instant, D3, D4 will start conducting. I hope it is clear. Otherwise, D3, D4 will not conduct. Okay. Let's say the D3, D4 will start conducting at this instant. At this instant, D3, D4 will start conducting. Now, at this instant, you can say that the supply voltage is negative. So, now D3, D4 will start conducting, and the current will start flowing like this. Current will start flowing like this. Okay. So, the output voltage will again remain 150. But this time, what will happen is, this time, the current will go in a reverse direction. Current will go in a reverse direction. Now, the question is, how to calculate this I naught peak? I understand everything. How to calculate I naught peak? Look, we know one thing, and that thing is, we know that the average voltage across this inductor has to be zero. Wait a minute. The average voltage across this inductor has to be zero. Okay. Then only the current will be periodic. If you want that the current is periodic, then the average voltage across this inductor has to be zero. Now, if we can plot the average voltage across this inductor, then it is easy to calculate the peak value of the inductor current. Okay. Then it will be easy to calculate the peak value of the inductor current. Now, how to calculate the peak value of inductor current? Tell me, guys. Because we know that, let's say at this instant, again D3, D4 start conducting. What will happen is, again the voltage across the inductor will be positive and current will will start rising. Okay, but this time the current will be in reverse direction. This time the current will be in reverse direction. So now the question is how to draw the voltage across inductor. Once you get the voltage across inductor, you can easily calculate the peak current. Okay, so the question is all about peak peak current of this I naught or peak current of this inductor current. Okay, so we need to plot the voltage across the inductor. From that voltage we can calculate the peak value of the current. Okay guys, so tell me how to do that. I have solved many questions like this. So please try to solve this question. This is not difficult question. I have given you the idea how to solve this. If somehow we can plot the inductor voltage, from that voltage we can analyze the maximum value of this I naught T. Okay, we can calculate the peak value of this output current. Now tell me how to do that. Tell me guys. Okay, first, this is the RMS voltage. We know that. What is the maximum value of the supply voltage? Maximum value is 120 root 2. 120 root 2. Now what is this 120 root 2 value? If you calculate this 120 root 2, let me check this numerical value. So the 120 root 2 value came out to be, wait a minute, I think I have already calculated this, or what I can do is I can calculate 120 into root 2. Okay, so it came out to be 169.70. Okay, this is the maximum value of the supply voltage. Now what I can do is, so we have calculated this value. Now we can plot the current equation. We can write the current equation. How to write the current equation? It's easy. What we can do is, let's write the current equation. How to write the current equation? We know that across inductor we have two. On this side we have AC supply. On this side we have DC supply. Okay, because D1, D2 are conducting. It means on this side we have 150 volt. On this side we have 120 root 2 sine of omega t. So now let's write the current equation. First, let's write the current due to this source. So the current due to this source will be 120 by root 2 sine of omega t divided by omega L. And angle will be minus 90. This is my steady state current due to this source, because AC transient method will be applicable. So if you solve it, it will be 1 by 120 root 2 divided by omega L. Omega is 2 pi f, 120 pi, and L is 1 millihenry, 10 raised to power minus 3. Okay, and sine of omega t minus 90. So this is the steady state current due to this source. But we know that this current has to be 0 at omega t equal to, at what instant this will start conducting? Let's call it theta. At this instant theta, the current will start conducting. So at omega t equal to theta, it has to be 0. It has to be 0 at omega t equal to theta. But at omega t equal to theta, it is not becoming 0. It is becoming sine of theta minus 90 with this amplitude. So what I can do is I can take minus of 120 root 2 upon omega. Omega is 120 pi into 10 raised to power minus 3 into sine of theta minus 90. Okay, so this is the current due to this AC source. What is the current due to this DC supply? Minus E by L. E, what is E? E is 150 upon L, 10 raised to power minus 3 E by L, or in divided by omega. Omega is 120 pi omega t minus theta. Okay, so this is the entire equation of the current. Now we need to calculate the peak value of this current. we know that the peak value will occur at this instant. This is pi minus theta. Because from this instant to this instant, the voltage across the inductor is positive. Since the voltage across inductor is positive, the current will keep on rising. If the current will keep on rising at this instant, the current will be maximum. So now the question is, what is the maximum current? So what you can do is, in place of omega t, you can put omega t equal to pi minus theta. If you put omega t equal to pi minus theta, the first term will become, so IT max will be equal to, 120 will cancel, okay? That will be root 2 by pi into 10 raised to power 3 into sine of omega t equal to pi minus theta. So pi minus theta will become sine of theta minus 90, okay? Sine of theta minus 90 minus, this is cancelled, root 2 by pi into 10 raised to power 3 sine of theta minus 90. So this will cancel, I suppose. Okay, you can see that this will cancel. Minus 150 upon 120 pi into 10 raised to power 3. At place of omega t, you put pi minus theta. So it will become pi minus 2 theta. Okay. So this is the current expression, and in this current expression, what I have done is, I have put this instant, because at this instant the current will be maximum, and this instant is pi minus theta. So in place of this omega t, I have put pi minus theta. Okay. So if you put pi minus theta, it will be, I think, minus theta minus 90. Wait a minute. Okay. Now the question is, what is this theta? What is this theta? Minus theta minus 90. Now the question is, what is this theta? We need to calculate this theta value, and theta value can be calculated using this graph. Theta will be equal to sine inverse of 150 upon 120 root 2. Okay. This way you can calculate this theta value, and you can put it here to calculate the maximum value. So let me tell you guys what is the maximum value. It's a difficult question actually. Okay. So let me calculate this value. This came out to be, so this theta came out to be 62.11 degree. Now if you want to put it if you put this value in the equation, then the current peak value will came out to be 33.76. okay. So this came out to be 33.76. so it's a difficult question actually. It's a lengthy question, but not difficult. I mean, not that much. It's a calculative question. Okay. What you need to do is, you just need to check at what instant this current will be maximum. At the same instant, this current will be maximum. Okay. And we know that the voltage across the inductor is supply voltage minus this output voltage. Okay. So this is the voltage across inductor, and during this interval, inductor voltage is positive. Since the inductor voltage is positive, the current will rise. Okay. And it will reach to the maximum at this instant. So I have written the current equation. In that current equation, I have put omega t equal to pi minus theta. Okay. At this instant, the current will reach the maximum. I hope you can solve this accordingly. Let's come to the next question, guys. This is the next question on your screen. In the following chopper, the duty ratio of the switch is 0.4. D is given as 0.4. If the inductor and the capacitor are sufficiently large to ensure the continuous inductor current, okay, it is given that the inductor current is continuous. If the inductor current is continuous, this is a buck converter. In buck converter, we know that the output voltage V0 upon VD, VD means the supply voltage, has to be equal to the duty ratio. Okay. So from here we can calculate the V0 value. V0 is equal to 20 into this duty ratio. So it came out to be 8 volt. Okay. Since the conduction is continuous, we can apply this formula. So the output average voltage came out to be 8 volt. Okay. Now it is given that the conduction inductor current is continuous and ripple free. Capacitor voltage, the charging current of the 5 volt battery, we need to calculate this current. We need to calculate I charging. Now how to calculate this I charging? I think it's very simple. the current will be 8 minus 5 upon 3. That came out to be 1 ampere. Okay. So the charging current has to be 1 ampere. I think it's easy peasy. Okay. So this was again a simple question and we have easily solved it. Let's come to the next question, guys. So do it, do this question. Please try to solve this question. I think it's easy peasy again. This question you can solve it easily. Please do it. Please do it, guys. Tell me the answer of this question. I think it's easy question. Now this is your turn. Now this is your turn. You have to solve it. For a simple chopper circuit, Vs is 200 volt. It is given that this is 200 volt. Okay. The average and the RMS value of the load current for duty ratio. Duty ratio is given as 0.49. We need to calculate average and the RMS value of load current. Average and the RMS value of the load current. Okay. For a duty ratio of 0.49. Neglect the voltage drop across the chopper. Okay. It is, he is saying that we have to neglect the voltage across this chopper. So please do it. I think it's easy peasy. Do it fast, everyone. Let's see how many of you can solve it. Do it fast. Do it fast. Everyone, do it fast. Do it fast. It's easy peasy. What we can do is the switch is turned on and off. So first let's plot this voltage. If somehow we can plot this voltage will be, when the switch is on, this voltage will be 200 volt. For dt time, for t on time. T on means dt time. And then it will be off for the next t time. Up to t time, it will remain off. Okay. It will remain 0 up to t time. And then again it will be 200 volt. So this will be the voltage wave at, let's call it V01. Okay. Now we know that the load will be RL type of switch. The load is RL type of load. Okay. And the voltage is periodic. We know that. If the voltage is periodic, this current has to be periodic. If this current is periodic, then the average voltage across inductor will be 0. If the average voltage across inductor is 0, it means whatever the average of this output voltage has, the same average will be available here. Now tell me the average output voltage of this. V01 average, and that will be equal to 200 into dt divided by t. So it came out to be 200 into d. This is the average output voltage, average voltage across this diode. The same average will appear here. So the average current will be 200 into d divided by the resistance value, that is 10 ohm. Okay. And this 0 I have cancelled it, so it will become 20D. Okay, so the average current in this load is 20D. Now what is duty ratio? Duty ratio is 0.49. So if you multiply it with 0.49, it will be approximately 9.8. Okay, only one answer is correct. Answer is Agra. Okay, so you can calculate the average and the RMS value of the load current. So average value of the load current has to be 9.8. Okay, only one option is satisfying. Only one option is satisfying. That is Agra. I don't need to calculate the RMS value of the current. Now, how to calculate the RMS value? Let's say we need to calculate. Let's calculate RMS value of the current. It's very difficult to calculate the RMS value because in the average value, what we have done is we have calculated the average value of this voltage divided by the resistance we have done. Okay, because we know that the average voltage across inductor is 0. But while calculating the RMS current, you cannot do like that. In case of RMS current, you have to plot the current wave shape. Okay, you have to plot the current wave shape and you need to apply the formula for the RMS. Okay, then only you will be able to calculate the RMS value of this current, which is very difficult. It's a lengthy process. But luckily, we don't need to do that because using this 9.8, there is no other option in which the 9.8 is given in the first part. Okay, so that's why it's easy for us to solve. Okay, but let's say in D option also it was given as 9.8. Then you have to go with the RMS current also. And for calculating the RMS current, you have to plot this wave shape, and then you have to apply the RMS formula, which is very lengthy. Okay, but there is no other way. I hope it is clear. But luckily, we don't need to do that. Okay, let's come to the next question, guys. This is the next question on your screen. An inverter has periodic output voltage with output waveform as shown in the figure. So we have this output voltage wave shape. Okay, so this is the output voltage wave shape, and this is pi interval. This is given as pi interval, and here you have a 0 interval. Okay, from this interval is alpha. Okay, so we know that in pi alpha, during the alpha region, the output voltage is 1 volt. Okay, so the remaining interval is pi minus alpha. So you can say that this is pi minus alpha by 2, and this will be pi minus of this interval. Okay, so pi plus alpha by 2. I hope it is clear. Okay, I hope it is clear. So we have calculated this point, this instant, and this instant. Okay, because it's symmetric structure. Na? This entire length is pi. Out of this pi length, alpha duration, in the alpha duration, the output voltage is 1. So the remaining duration is pi minus alpha. Out of that duration, 50% is on this side and 50% is on this side. Okay, so you can write this interval, write this instant, pi minus alpha by 2, pi minus alpha by 2. Now, okay, alpha is already given to us. Now, alpha is 120 degree. So if you put alpha equal to 120 degree, then this will be 30 degree. This interval is 30 degree. This interval is 180 plus 120 by 2. That is 150 degree. Okay, so this is 150 degree. This is 30 degree. The RMS fundamental component of the output voltage. We need to calculate the RMS value of the fundamental component. Now, how to calculate the RMS value of the fundamental component? Using quarter wave symmetry. You can calculate using quarter wave symmetry. This is my pi by 2 interval, and we know that this wave has quarter wave symmetry. If this wave has quarter wave symmetry, then the fundamental peak will be 4 by pi, and from 0 to pi by 2 you have to write the function, but between 0 to 30 there is no signal. So I start from 30 to pi by 2. Why I have written from pi by 6 to pi by 2? Because 0 to pi by 6 there is no signal available. So that's why pi by 6 to pi by 2, the function has amplitude 1 into sine of omega t d omega t. Okay, you need to calculate like this. This is the peak value of the fundamental voltage. Now what is the RMS value? Let's first calculate this. So 4 upon pi, and this came out to be, integration of sine is minus cos. Upper limit is 0, lower limit is cos pi by 6. Okay, so this is my peak value of the output voltage divided by root 2. This will be the RMS value of fundamental. Okay, peak value divided by root 2 is the RMS value. Now you can calculate this value. Cos 60 is root 3 by 2. So it will be 4 by pi root 2 into cos 60. Cos 60 is root 3 by 2. Okay, I hope it is clear. So you can solve it like this. So I think it's easy peasy, and you can check the decimal value. Tell me guys, which option is correct? You can check the decimal value. So let me check which option is correct for this. Wait a minute. Yes. So which option is correct? I think Agra is correct. The value is 0.78. 0.78. Answer is Agra. Okay. So the value came out to be 0.78. Answer is Agra. Okay, let's come to the next question, guys. Let's come to the next question. In the next question, a single phase voltage source inverter is feeding a purely inductive load as shown in the figure. We have a purely inductive load. Inverter is operated at 50 Hertz, 180 degree square mode. Assume that the load current does not have a DC component. This current does not have DC component. The peak value of the inductor current I naught. Let's call it I naught. Okay, we need to calculate the peak value of the inductor current. How to calculate? First, let's draw the voltage across inductor. If you want to draw the voltage across inductor, we know that when T1, T2 are conducting, output voltage will be positive at 200 volt. Okay, at 200 volt, and then it will be at minus 200 volt, and then it will be again at plus 200 volt, and then minus 200 volt. So the voltage will go like this. Voltage will go like this, plus 200 and then minus 200 and then plus 200 minus 200. Okay, so the voltage will go like this. Now What about the current? It is given that the load current does not have any DC component. It means there should not be any DC component in this current. So the current, since the voltage across the inductor is constant, the current will be linearly rising, okay, and then it will be falling. But we know that, but it is given that the DC component of the current has to be 0. It means the current will be symmetric. Current will be symmetric about the, it means whatever the negative value is, the same will be the positive value. So let's call it I0 minus I0. So this has to be plus I0, so that the average value of this current becomes 0. Okay. Now the question is, what is this I0 value? What is this peak value? That you can easily solve it using the inductor equation. We know that in inductor the current IT is equal to I0 plus 1 by L integration 0 to T VLT dt. Okay. Now we can apply the same rule. We know that this is T by 2 interval. Okay. This is 0. This is T by 2. So we need to calculate the current value at T equal to T by 2. And the initial current is minus I0. So minus I0 plus 1 by L from 0 to T by 2 VLT. VLT is 200 dt. And this current has to be equal to I naught. This current has to be equal to I naught. Okay. Now what you can do is you can take this I naught on the other side. So it will be 2 I naught is equal to 200 by L. And what is this L value? L came out to be 0.1 Henry. 200 by L into T by 2. Okay. Now this I naught will be equal to, from here you can calculate the I naught value. I naught will be equal to 200 into T divided by 0.1 into 4. Why it is 4? Because this 2 I have taken in the in the denominator. Okay. Now let's cancel it. It will be 50 divided by 0.1 is 500 T. Okay. 500 T. So this is my peak value of the current. Now what is this time period T? T is 1 by F. 1 by F is 1 by 50. So if you put T equal to 1 by 50, the answer is 10 ampere. So the answer is Bombay. Okay. Answer is Bombay. Answer is 10 ampere. So this question was again easy peasy. Okay. This question is again easy peasy. So this was the last question. Now let's come back to this question. Now this is a very good question again. So let's try to solve this question. And this is again a very difficult and not that much difficult, but actually it's a tricky question. A solar cell of 350 volt is feeding power to AC supply 50 hertz through a 3-phase fully controlled bridge converter. A large inductance is connected in the DC circuit to maintain the DC current at 20 ampere. If the solar cell resistance is 0.5 ohm, then the thyristor will be reverse biased for a period of. For how much period the thyristor will be reverse biased? Okay. सर थोड़ा ऑफ टॉपिक है, सॉरी टू डिस्टर्ब सर. एमटेक के लिए एज तक में कर लेना चाहिए आइडली 26. नहीं कोई दिक्कत नहीं है, आप टेंशन मत लीजिए. एज फैक्टर एज मैटर ही नहीं करती, ठीक है. स्किल्स मैटर करती हैं. चाहे आप वो 28 की एज में लेके आओ, चाहे 27 20 चाहे 30 की एज में लेके आओ, स्किल्स कंपनी मांगती है. तो आप एज को लेके टेंशन मत लीजिए, ठीक है. तो आप कीजिए एमटेक अगर आपके पास ऑप्शन है तो, ठीक है. 26 ज्यादा एज नहीं है, ठीक है. और 2 ईयर का गैप भी मैटर नहीं करता है, ठीक है ना. तो आप इस चीज के लिए परेशान मत हो. लेट्स कम बैक टू द क्वेश्चन गाइस. सो वी हैव ए 3-phase fully controlled bridge converter. Okay. So the load is like this, RLE load. Since the load is delivering power back to the source, that's why the polarity of the source should be like this. Okay. And it has to be 350 volt. And the resistance is 0.5 ohm, and it is given that the current is continuous at 20 ampere. Okay. Now if this current is constant at 20 ampere, this drop will be of 10 volt. Okay. Now what about the output voltage? This output voltage of this polarity has to be minus 340. Okay. V naught T average has to be equal to minus 340 volt. Okay, now if it is minus 340 volt, then we need to calculate the alpha. What is the alpha value? So the average output voltage in 3-phase full bridge converter is 3 root 3 Vm by pi cos alpha. It has to be minus 340. So we can calculate the value of alpha from here. Okay, alpha will be equal to, now what is the value of alpha? Let me check the calculator if I have. I don't think that I have the calculator, but anyway, we can calculate this value, cos inverse of minus 340 pi divided by 3 root 3 into Vm. What is Vm? Vm is the maximum value of the phase voltage. It is given that this is the line voltage RMS value. So line voltage phase value will be the line voltage RMS value is given. The phase voltage RMS value will be 440 by root 3. This is the RMS value, but we require the phase voltage max value. So the phase voltage max value will be phase voltage RMS value multiplied by root 2. Okay, I hope it is clear to everyone. Now let's calculate this alpha. Now what is this alpha? What is this alpha? This alpha came out, obviously it should be greater than 90. So let's calculate this value first. To calculate this, I need the calculator. So let's use the calculator and try to calculate this value. 340 into pi divide by this root 3 is cancelled. Okay, divide by 440 divide by 3 root 2. 3 root 2. Okay, and it came out to be 0.57. Alpha equal to cos inverse of minus of 0.57. Now let's calculate this value. So I need to do the cos inverse. Okay, let me check, guys. Okay, cos inverse of minus 0.57. So this value came out to be 125. Okay, so this came out to be 125 degree. It means alpha is 125 degree. Now we need to calculate for what interval the thyristor is reverse biased. Now it's a challenging problem, because till now we have calculated the firing angle alpha, but in this question we don't require the firing angle because the firing angle is not asked. They have asked for what interval the thyristor will be reverse biased. Okay, so let's try to solve that. We know that this is my thyristor, this is my okay, now we need to plot. Let's assume that the current is constant at 20 ampere, continuous conduction is there. Okay, now we need to plot the voltage across the thyristor T1. We need to plot the voltage across the thyristor T1. If somehow we can plot this, then we can get the idea. We can get the idea that for how much interval this will be reverse biased. Okay, so let's first draw the line voltages. Let's first draw the line voltages. Now it's a tricky question. Okay, I mean, not that much tricky. It's a calculative question, nothing else. Let's say we have these line voltages. Okay, these are the line voltages. And the conduction is continuous, remember that. Okay, now you can see that this is VAB, this is VAC. After VAC we have VBC, then we have VBA, then we have VCA, then we have VCB, then we have VAB. Okay, So before VAB we have VCB. Fine. Now let's say, let's not take alpha as some value. Alpha is 125 degree. Let's take alpha as some, maybe some alpha note. Okay. Now you can see that if alpha is 0, thyristor T1 will start conducting at this instant. And since the subscript is A subscript means this thyristor is conducting. This A phase is available at the upper point. If A phase is available at the upper point, it means T1 is conducting. So from this interval to this interval, let's say alpha is 0. Let's plot for alpha equal to 0. For alpha equal to 0, you can see that from this interval to this interval, thyristor T1 is conducting. Okay. From 30 degree to 150 degree. From 30 degree to 150 degree, T1 is conducting. Now what will happen? From 30 to 150 degree, so if I want to draw the voltage wave shape VT1, it will be 0. For alpha equal to 0, I'm plotting. It will be 0. Now from this interval, from this instant, VBC is conducting. It means the upper point is at B. Upper point is B and the lower point is A. It means the voltage across the thyristor is VAB. Voltage across this thyristor T1 is VAB for the next 60 degree. And VAB is this voltage. So this will be the voltage across the thyristor, VAB. It is reverse biased, okay? For the next 60 degree, up to this interval, this will be the voltage across the thyristor T1, okay? Now, after that, it will be VBA. It means the upper point will be again at B voltage, upper point will be B voltage because the first subscript is B, na? So the upper point will be B and this point will be A. So the voltage across thyristor T1 is again VAB and VAB is still this voltage. So for the next 60 degree, it will be VAB like this. Okay. So this will be the voltage across thyristor T1. Now from this interval onward, from this instant onward, what will happen? Voltage is VCA and then VCB. It means this voltage is C. Okay. So the thyristor voltage is VAC. We need to plot VAC. What is where is VAC? VAC is this voltage. It means you can see that for the next 120 degree VCA and VCB. It means the upper point voltage is C and at this point we have A. So this voltage will be VAC. So VAC will be there for the next, this is my VAC. VAC will be there for the next 120 degree. It means up to this point. After this point, again VAB will start conducting. Okay, again VAB will start conducting. Is it clear, guys? Now if alpha is 0, you can see that if alpha is 0 for 240 degree interval, thyristor T1 will be reverse biased, and for 120 degree interval thyristor T1 will be forward biased. Now let's say alpha equal to alpha naught. If you take alpha equal to alpha naught, then what will be the wave shape of VT1? Okay, so let's try to plot the wave shape of VT1. Okay, now I have taken alpha equal to alpha naught. Let's say this is my alpha naught. Let's say 30 degrees alpha naught. Alpha naught is taken as 30 degree. Okay, now from this interval to this interval, the output voltage is 0. I mean the voltage across the thyristor is 0 because thyristor T1 is conducting from this point to this point. Okay, now from this point onward, VBC will be there. This is my VBC. Okay, this voltage will be available, VBC. Okay, VBC will be up to this interval. Okay, first VBC will be there and VBC up to this point it will be VBC. Wait a minute, guys. At this instant VAC will stop. Okay, because at this instant what will happen is VAB will start conducting and then at this interval VAC will start conducting. Okay, it means the thyristor T1 is conducting. Now at this interval VBC will start conducting. If VBC is conducting, it means the upper point is at B and this point is at A. So the thyristor voltage will be VAB. So from this point onward, the thyristor voltage will be VAB up to what instant? Up to this instant. Up to this instant, thyristor voltage will be VAB. This is VAB. Now again, after this point, VBA is conducting. Up to this instant, VBA is conducting. If VBA is conducting up to this, again the upper point is at B and this point is at A, so the voltage across thyristor is VAB. So VAB is the same voltage. So up to this instant VAB will go like this. Okay, up to this instant VAB will go like this. I hope it is clear. From this interval, from this instant to this instant to this instant. Okay, this is my VAB. Now from this point onward, VCA is there. If VCA is there, what will happen? Tell me guys, if VCA is there, VCA means the upper point is at C. So the thyristor voltage will be VAC. From this point onward, we have VAC as the thyristor voltage. VAC is this. This is my VAC. So from this point onward, we have VAC as the voltage, output voltage. Okay. So VAC up to this interval, VAC. And then again, from this interval to this interval, again we have VAC. Okay. This is the voltage across the thyristor. Now you can see that this is the voltage across thyristor, and again it will be 0 voltage. Now you can see that out of this, the first 120 is conducting, but the remaining 240, out of that 240, it is not always reverse biased. Thyristor will become forward biased after that point. This voltage is positive after this point. It means 240 minus alpha naught interval. 240 is this interval minus this alpha naught. For 240 minus alpha naught, the thyristor will be reverse biased. If the thyristor is fired at alpha naught, then for 240 minus alpha naught, the thyristor will be reverse biased. So the answer is 240 minus this 125. Alpha naught you can take 125, na? So for this angle, the thyristor will be reverse biased. So the answer is 115. No option is provided to you. 115 is not given in any option. So the answer has to be 115. I don't know how many of you have understood it. For some firing angle alpha naught, you can see that. For some firing angle alpha naught, you can see that. For 120 degree thyristor is 0 voltage. This thyristor is conducting. But for next 240 degree, 240 minus alpha naught, it is reverse biased. 240 minus alpha naught, it is reverse biased. Voltage across the thyristor is negative. Okay, and then it is positive again. So 240 minus alpha naught, this is the reverse voltage. Okay, so what you can do is alpha naught is provided to us. Alpha naught is 125. So 240 minus 125 is the correct answer. Answer is 115. So no option is matching. I have provided with this answer, but this is not the correct answer, guys. This is wrong answer. Why? Because this answer is valid for alpha naught. I think in this question he wants to calculate the firing angle alpha naught. Okay, but if he wants to calculate for what interval this thyristor T1 is conducting, so this will be 240 minus alpha naught. Okay, so that interval, for this interval, thyristor will be reverse biased. So the answer is 115 degree. I hope it is clear to everyone. So this was again a tricky question, and please try to look at this question. So these were the questions, guys. I hope you enjoyed this session. Don't forget to like this session and please subscribe our channel and press the bell icon so that you get the notification whenever I'll be live. Okay, so that's all for today's session, and see you in the next session, guys. Next session will be at 9 PM with network theory. So in that session we will discuss about basic laws. Okay, so let's stop it here, and thank you for showing interest in this class. I hope you enjoyed. See you in some other session. Thank you and take care. Bye.